Hello, friends. Welcome to the Awesome Algebro. Today, we're going to be going over function notation. Luckily, this is one of the easier concepts in algebra. So, the definition of function notation is it's a rule where you put in a number, the input, and it gives you an answer, the output. The x is the number that you put in, and the f of x, or the y, is the number that you get out. Now, the example we're going to use today is f of x equals 3x squared plus 5. We're going to take a look and see what happens if we actually plug in or input a number. The number we're going to input today is going to be f of 4, and we're going to find out what our output is going to be. So, as we look, we see f of x equals 3x squared plus 5. Function notation works like this. It's essentially saying the f of x is your input. That's your domain. That's the x-axis. This stands for your x-axis, what you will put in. The 3x squared plus 5, the answer to this will be your output, your range, your y-axis. It's essentially saying whatever you put in for x, what do you get out as an answer, which is your y. So today's example is going to use f of 4, which means if you input 4 for every x, what will be your output? Or in another way to say it is, if you replace every x with the number 4, what will your answer be? What would your output be? So let's take a look at our example one more time. F of x equals 3x squared plus 5. So f of 4 is saying if you input 4 for every x, so that is an x, here's another x. Our x is here, our x is there. It's asking us if we input 4 for every x, what will be our answer? So at this point, every time we see x, we're going to replace it or input the number 4. So let's do that now. Every time you see x, input 4. We see an x, we replace it with a 4. We see another x, simply replace it with a 4. Be sure to include it with parentheses. Now at this point, we just need to solve and do our math work. So on the output side, we're going to find 3 times 4x squared plus 5, and that will give us a result of 48 plus 5. And if we solve for 48 plus 5, that will give us 53. So our f of 4, meaning if we input 4, we get out 53. Where the first part, f of 4, that's our input. Our x is equal to 4. But 53 is our output, where our y is equal to 53. So if we were to make a coordinate out of this, the first number, x, is our input. The second number, 53, would be our y, which would be our output. So function notation is simply asking you to replace or input the first x variable with every x variable that you see for the rest of the problem. Now, let's look at a few more examples and see if we can have more success with those as well. Okay, let's look at a few more examples. Let's start with f of x equals 8x minus 5. In this case, remember, always focus on your x values. Every time you input an x here, you're going to input with every x in the problem. So your x's are always your input. So whatever you do for one x, you need to replace it with all the x's. So in this case, let's input our f of x as negative 2. Now, every time we see any x, now we're going to input it or replace it with negative 2. So let's do it. So now f of negative 2 equals 8 times negative 2 minus 5. Well, simply, we just do the work. 8 times negative 2 is negative 16. And then we realize that would be negative 16 minus 5, whatever answer that happens to give us. And when we do the work for that, we get negative 21. So we can see f of negative 2 equals negative 21, where it essentially says every time you see negative 2 for your x, replace it with every x in the problem. So negative 2 was our input, our x value, our domain. Negative 21 was our output, our y value, which is our range. So if you input negative 2 for every x, you should get out negative 21 for your y value. And that gives us a coordinate of -2, -21 for our x values and our y value. And it essentially means this. If you input -2 for every x, you should get out -21 for your y. Let's look at another problem. In this case, g of x equals 20 minus 5 times x minus 4. Please realize you won't always get f all the time. You can get any letter. G of x, h of x, p of x, whatever letter you can think of. Now, in this case, remember, always focus in on the input. Your x is your input. That means every x is going to get your input number. In this case, let's look at our input for our x's, and let's use a number like 10. Let's input 10 for all of our x values. So g of 10 is going to give us our answer. So if we input 10 for every x value, what would our answer be? Well, we see x here. Let's input it with 10. So we solve it as usual. We need to solve for parentheses because PEMDAS tells us to do so. 10 minus 4 is 6. Let's bring down all the rest of our work, which will give us g of 10 equals 20 minus 5 times 6. And once we solve for 20 minus 5 times 6, we should get -10. So g of 10 equals -10, which means our input is 10, our x is 10, that's our domain. Meaning if we input 10 for every x, we should get an output of -10 for our y. So our input, our domain is 10, but our output, our range would be -10. So our x is 10, our y is -10, and it just simply means this. If you input 10 for every x, you should get -10 for your output, for your y. Just to see if we understand this, let's go over a very tough question. -3f of -2 plus 5g of 10. When you see that problem, it's going to look tough at first. You're going to see it and you might not have a clue on earth what to do. But if you follow me, I guarantee you're going to know what to do. Look at the problem again. Look at this problem here and here. Those should look familiar because we just solved those problems. F of -2, we just solved. And G of 10, we just solved. What is F of -2? It's -21. We just solved it. What is G of 10? It's -10. We just solved for that. So all we have to do is multiply the numbers that are next to it in the problem. It said -3 times F of -2, which is -21, plus 5 times G of 10, which is -10. Well, if we just do the math work for it, that should give us positive 63 plus -50. And if we do the math work for that, that should give us positive 13. Now that we've seen how to do this problem, let's see how it looks when we do the same problem using DESMOS, the calculator app. Okay, friends, we're going to take a look at DESMOS, the calculator app. You can use this by going to desmos.com, or you can just download the DESMOS app to your phone. We're going to take a look at a sample problem that I'm going to make up. I'll say h of x equals 9x to the third plus 5x minus 7, something like that. DESMOS is extremely useful, very powerful calculator tool because it can actually help you to solve the questions within seconds as long as you input the input correctly. Remember, the first part will always be your input, the second part will always be your output. So let's play around with a couple of examples and you're going to be shocked and amazed. Let's say I want to solve for my input is 8. So I will put h of 8, and there's my answer, 4,641. Let's try a number of h of -2, -89. And let's say, just to check it, now I know it has to be correct if I plug in 0. If I plug in 0, this will cancel out, this will cancel out, should leave me with -7. So I'll put h of 0, and what do I get? -7. So I hope using DESMOS will also be a valuable tool to help you solve for function notations very quickly, very accurately. Be sure to just understand, whatever you put for x is always your input. It will replace every x in that problem, and your answer will always be your output. I hope this helped very much, and I hope you have great success in your function notation equations. Hey friends, thanks for watching the awesome Algebro. Please be sure to like, comment, share, and subscribe for the most awesome algebra tips available. And again, thank you for making me a part of your day.